Download this code from codegive.com, link in the description below. Are you leaving your Microsoft Graph tokens unprotected? A deep dive and secure coding guide. The Microsoft Graph API is a powerful gateway to data and intelligence within Microsoft 365. However, mishandling authentication and authorization tokens can expose your application and user data to serious security risks. This tutorial explores common vulnerabilities that leave Microsoft Graph tokens unprotected, provides code examples demonstrating the problems, and offers practical solutions for securing your application. Understanding the risk, why protect tokens? Imagine the Microsoft Graph token as a skeleton key to a treasure chest containing sensitive data, emails, documents, calendar events, user profiles, and much more. If this key falls into the wrong hands, the consequences can be dire. Data breach, unauthorized access to user data, potentially leading to financial loss, identity theft, and reputational damage. Account takeover, malicious actors can use stolen tokens to impersonate users, sending emails, modifying documents, and changing account settings. Privilege escalation, if the compromised token has elevated privileges, example access to administrator accounts, the attacker can gain complete control of the organization's Microsoft 365 tenant. Reputational harm, a security breach can severely damage trust with users and partners, leading to financial losses and legal liabilities. 2. Common vulnerabilities, how tokens get compromised. Here are the most prevalent ways Microsoft Graph tokens are inadvertently left unprotected. 1. Storing tokens in client-side code, JavaScript, mobile apps. This is perhaps the most common and egregious mistake. Client-side code, especially JavaScript running in a browser, is inherently insecure. Anyone can inspect the code and storage mechanisms using browser developer tools. Problem: tokens stored in JavaScript variables, local storage, session storage, cookies, without proper security flags, or even hard-coded into the code are easily accessible to attackers. Example: vulnerable JavaScript code. Explanation: the access token is either hard-coded directly or stored in local storage, both easily accessible through browser dev tools. An attacker can simply open their browser's developer tools, usually by pressing F12, navigate to the Application tab, for local storage/session storage, or the Sources tab to inspect the code, and extract the access token. Mitigation: never store tokens in client-side code. Use a secure server-side application to handle authentication and authorization. The client-side application only interacts with the server, which then securely handles the token. Consider using the authorization code flow with PKCE for single-page applications, SPAs, as explained below. 2. Incorrectly configuring authentication flows. Using the wrong authentication flow or configuring it improperly can lead to vulnerabilities. For example, using the implicit grant flow, now deprecated, in SPAs is inherently less secure than the authorization code flow with PKCE. Problem: implicit grant returns the access token directly to the browser, making it susceptible to interception. Example: vulnerable implicit grant flow. This example demonstrates the insecure implicit grant flow which is now deprecated. Do not use this. Explanation: after authentication, the access token is returned in the URL fragment, access_token equals, of the redirect URI. This means the token can be visible in browser history and potentially logged by proxy servers. Asterisk implicit grant doesn't support refresh tokens, limiting the app's ability to obtain new access tokens without re-authentication, leading to a poor user experience. Asterisk it's vulnerable to token replay attacks. Mitigation asterisk. Asterisk authorization code flow with PKCE, recommended for SPAs. This is the most secure flow for SPAs. It involves exchanging an authorization code, obtained after user authentication, for an access token and refresh token through a secure server-side process, mitigating the risk of token interception. PKCE, proof key for code exchange, adds an extra layer of security by preventing authorization code interception. Asterisk client credentials flow. For server-side applications, use this flow when your application needs to access data without user interaction, example background processes. Store the client's secret securely on the server. Asterisk on behalf of flow. For APIs calling other APIs, this flow allows an API to securely delegate user identity and permissions to another API. 3. Insufficient token validation ****. Failing to validate the integrity and authenticity of access tokens can leave your application vulnerable to token forgery or tampering. Problem ***. If you don't verify the token's signature, issuer, audience, and expiration time, an attacker could potentially create a fake token and gain unauthorized access. Example: insecure token validation, simplified. Explanation ***. The validate token function uses JWT.decode to decode the token. Critically, this function only decodes the token's payload, it doesn't verify the signature. An attacker could create a token with a manipulated payload, example changing the user ID, and, if the signature isn't verified, the application would incorrectly treat it as valid. The code only checks for expiry but doesn't verify the other critical fields, issuer, audience, etc. Mitigation verify the token signature use a JWT library, like JSON webtoken in Node.js or libraries specific to your language, to verify the token signature against the public key provided by Microsoft Entra ID, formerly Azure AD. This ensures that the token hasn't been tampered with. Validate the issuer ensure the ISS, issuer, claim in the token matches the expected issuer for your Microsoft Entra ID tenant. Validate the audience verify that the AUD, audience, claim matches your application's client ID. This prevents the token from being used by other applications. Check the expiration time ensure the EXP, expiration time, claim is in the future. Revocation checks implement a mechanism to check for revoked tokens. While this can be complex, it significantly enhances security. Microsoft provides mechanisms for this, such as the revocation endpoint. Example: secure token validation with JSON webtoken. Explanation JWKSRSA library this library is used to retrieve the public keys from the JWKS, JSON web key set, endpoint exposed by Microsoft Entra ID. These keys are used to verify the token's signature. Get key function this function fetches the correct public key based on the key ID, header in the JWT. JWT.verify function this function performs the crucial signature verification step using the retrieved public key. It also validates the audience, client ID, and issuer. Error handling the try, catch block handles potential errors during token validation, ensuring that invalid tokens are rejected. 4. Logging tokens Accidentally logging access tokens in application logs, server logs, or debugging output can expose them to unauthorized access. Problem asterisk. If logs are compromised, the tokens contained within them can be used by attackers. Example, insecure logging. Mitigation asterisk. Asterisk never log tokens directly. Asterisk completely avoid logging the raw access or refresh tokens. Asterisk sanitize logs. Asterisk if you must log information related to authentication, redact the token value. For example, console.log, authentication successful for user, username, token length, length of token. Asterisk secure log storage. Asterisk ensure that your logs are stored securely, with appropriate access controls and encryption. Asterisk review and rotate logs regularly. Asterisk regularly review your logs for sensitive information and rotate them to minimize the window of exposure. 5. Insecure transmission of tokens. Asterisk asterisk. Transmitting tokens over an unencrypted connection, HTTP, makes them vulnerable to interception. Problem asterisk. Man-in-the-middle attacks can intercept tokens sent over HTTP. Mitigation asterisk. Asterisk always use HTTPS. Asterisk ensure that all communication between your application and the Microsoft Graph API, as well as any communication involving tokens, is done over HTTPS, SSL/TLS. Asterisk enable HTTP strict transport security, HSTS. HSTS forces browsers to only connect to your website over HTTPS, preventing downgrade attacks. Configure your web server to send the strict transport security header. 6. Storing refresh tokens insecurely, if used. Refresh tokens are used to obtain new access tokens without requiring the user to re-authenticate. If compromised, they can be used indefinitely to generate new access tokens. Problem asterisk. If refresh tokens are stored insecurely, attackers can use them to generate new access tokens even after the original access token expires. Mitigation asterisk. Asterisk treat refresh tokens with extreme care. Asterisk refresh tokens are highly sensitive and should be treated with the same, or greater, level of security as passwords. Asterisk encrypt refresh tokens at rest. Asterisk encrypt refresh tokens before storing them in a database or other persistent storage. Use strong encryption algorithms, example AES-256, and securely manage the encryption keys. Asterisk limit refresh token lifetime. Asterisk configure your Microsoft Entra ID tenant to issue refresh tokens with a limited lifetime and a refresh token inactivity timeout. This reduces the window of opportunity for attackers to exploit compromised refresh tokens. Asterisk refresh token rotation. Asterisk use refresh token rotation, which invalidates the old refresh token each time a new one is issued. This mitigates the risk of a compromised refresh token being used for an extended period. Microsoft Entra ID supports refresh token rotation. Asterisk consider proof of possession tokens, client certificates for very high security scenarios. Consider using client certificates or other proof of possession mechanisms to bind refresh tokens to a specific device or client. This makes it much more difficult for attackers to use compromised refresh tokens from a different location. 3. Secure coding practices and best practices. Here's a summary of best practices to safeguard your Microsoft Graph tokens. Asterisk server-side authentication. Asterisk always handle authentication and authorization on the server side. The client-side application only interacts with the server. Asterisk use appropriate authentication flows. Asterisk choose the correct authentication flow based on your application type. Asterisk authorization code flow with PKCE asterisk for SPAs and mobile applications. Client credentials flow for server-side applications that need to access data without user interaction. On behalf of flow for APIs calling other APIs. Secure token storage never store tokens in client-side code. Store refresh tokens, if used, securely on the server, using encryption and access controls. Token validation thoroughly validate all tokens before using them, including signature verification, issuer validation, audience validation, and expiration time check. HTTPS only use HTTPS for all communication involving tokens. Avoid logging tokens never log raw access or refresh tokens. Sanitize logs to remove sensitive information. Regular security audits conduct regular security audits of your application and infrastructure to identify and address potential vulnerabilities. Principle of least privilege grant your application only the minimum permissions required to perform its tasks. Overpermissioning increases the impact of a potential compromise. Stay updated keep your libraries, frameworks, and operating systems up to date with the latest security patches. Monitor for suspicious activity implement monitoring and alerting to detect unusual activity that could indicate a token compromise, example unusual login attempts, access from unexpected locations. Consider conditional access policies Microsoft Entra ID conditional access allows you to enforce policies based on user location, device compliance, and other factors, further enhancing security. 4. Code example, authorization code flow with PKCE, SPA. This example outlines the steps for implementing the authorization code flow with PKCE in a single-page application, SPA. Note, this is a simplified example and requires further development for production use. SPA, JavaScript, using missile.js library. Server-side, Node.js, simplified example for validation. Key points missile.js library the Microsoft authentication library for JavaScript, missile.js, is used to handle the authentication flow in the SPA. It simplifies the process of obtaining tokens from Microsoft Entra ID. Code verifier and code challenge The code verifier is a randomly generated string that is used to create the code challenge. The code challenge is sent to Microsoft Entra ID during the authorization request. Secure storage of code verifier The code verifier is stored in session storage, which is more secure than local storage because it is cleared when the browser session ends. Login redirect The login redirect function redirects the user to the Microsoft Entra ID login page. After the user authenticates, they are redirected back to the redirect URI specified in the configuration. Handle redirect promise The handle redirect promise function is called when the user is redirected back to the SPA. It handles the response from Microsoft Entra ID and extracts the authorization code. Acquire token silent and acquire token redirect The acquire token silent function attempts to acquire an access token silently, without user interaction. If this fails, example because the user needs to re-authenticate, the acquire token redirect function redirects the user to the Microsoft Entra ID login page. Server-side validation The SPA sends the access token to the server-side application for validation. The server-side application then validates the token using the public keys from Microsoft Entra ID. Never use the token directly in the SPA The access token is never used directly in the SPA to access Microsoft Graph. Instead, it is sent to the server-side application, which then uses the token to access Microsoft Graph on behalf of the user. Conclusion. Protecting your Microsoft Graph tokens is paramount to maintaining the security and integrity of your application and user data. By understanding the common vulnerabilities, following the secure coding practices outlined in this tutorial, and staying informed about the latest security recommendations, you can significantly reduce the risk of token compromise and build more secure and trustworthy applications. Remember to prioritize security throughout the development life cycle and regularly review your security posture. Always consult the official Microsoft Graph documentation and best practices for the most up-to-date guidance.